Just go along with me here as I rationalize some reasons that lambda expressions can be useful. So just go with me here for a moment. Imagine you wanted to pass some condition as a parameter. So a caller could specify a subset of files. As it is now in our examples, we're getting all of the files in a folder in the output list. What if you wanted to say, I only want files where the size is greater than 10,000 bytes? Well, you could hard code that condition in the procedure. And every time you wanted a different condition, you create a different procedure. It might be better to pass that condition as a parameter. So you pass basically a where clause as a parameter to your procedure. Like I said, maybe you want to specify that you'll only seek files within a specified size range. Maybe you only want files that begin with A. Maybe you only want executable files that are greater than 50,000 bytes. And without some help, there's no way to generalize this. We have no way built into simple language features to specify a condition on an if statement within code as a parameter without doing something special. Now you could use delegates. A delegate is a type that represents a particular kind of procedure. It defines the parameters and the return type on a procedure. You could pass an instance of a particular delegate type as a parameter to your file searching procedure. And the procedure could then call the delegate instance to filter the return values. In our case, the delegate instance should accept a file info as a parameter, so it can look at each file and determine whether or not to include that file. Therefore, it should also return a Boolean value. It takes in a file info, decides whether or not to accept that file info, and returns true or false back. We could call that delegate instance for each file we find in the collection of files when we call the getFiles method. Well, let's set this up and try some examples that demonstrate this behavior, which has nothing to do with new features. This is all old features. Let's give it a try. I'll choose option H, which hard codes the condition for us. Here, if I step into this procedure, you'll see that here we've hard coded a condition right here, which says we only want to accept files that are larger than 10,000 bytes. That will limit the results in our output, but it does require us writing a separate procedure for every different condition that we might want to use. So although this does work and we get fewer files, you can't tell, but we did actually get fewer files and none of them are smaller than 10,000 bytes. It's not an optimal solution if you need to be able to dynamically specify which files you want to include. Well, let's go on to the next one. In this version, we're going to use a delegate instance. So let's look and see how this works. Now remember, our file filter delegate should accept a file info as a parameter and return a Boolean value back. And here's the declaration for our delegate here. You define it by saying private delegate, the return type, the name of the delegate, and then any parameters it expects. Now that just defines a particular kind of procedure. What we want to do is pass an instance of that kind of delegate as a parameter to our procedure, because search for file 6 has two parameters it accepts, a path and an instance of this type. Well, we have a large files procedure. Let's go look at that. Large files says I'll only return true if the file length is greater than 10,000. Okay, well, back to where we were. Where was that? Well, let's just step in and we'll see. There we go. And now I'll display the results and show what we get when we pass in that file filter delegate instance named large files. By creating a new instance of this type, passing the address of the procedure we want to call in the constructor, we basically pass a pointer to that procedure into search for file 6. You can see that file filter delegate is the type and condition is the name of that variable. Basically, condition is a procedure. It's a function which takes in a file info object, returns a Boolean back. And so here inside our loop, we don't say if the file is greater than 10,000 bytes, we say if condition passing in fi returns true. If I step into that procedure, we pass in a file info, we check its length. If it's greater than 10,000, we return true. If it's less than 10,000, we return false. So in this case, we didn't add that file, and we'll do this for each file. This one must have been greater than 10,000 bytes, and so we do add this one. Well, that was great because now we were able to pass in the condition from outside the procedure. Now, just as a side note, you're welcome to create your own delegate type, as we did in that previous example. The file filter delegate type accepted a file info as a parameter and returned back a Boolean. But it's usually better to use a built-in delegate type if there is one that meets your needs. This is easier for consumers of your code to understand because these are well-known delegate types. They're documented in the .NET framework, and anyone can use them. In our case, the predicate delegate type fits our filtering need. The predicate type is a built-in delegate that accepts any kind of object. It is a generic delegate type, and it returns a Boolean value back. Its point in life is to do exactly what our file filter delegate did. The predicate delegate type describes a procedure which accepts a parameter of a specific type and returns a Boolean back. Let's look at our example, which is modified to use an instance of the predicate delegate type as opposed to our own file filter delegate type. I'll choose option J to test working with a predicate, and you'll see here that when I call search for file 6a, I'm just passing in large files or small files. Instead of creating a new instance of a delegate, I could have said new predicate large files, because predicate is a delegate type just like this is, but you don't have to. I could have written this code just specifying large files because large files was an instance of the file filter delegate type, and that's what search for file 6 was looking for. Large files is an instance of the predicate type, and that's what search for files 6a is expecting, a predicate, where file info is the object type, and we'll call it condition. Predicate is a predefined .NET framework type that takes in a generic type and returns back a Boolean value. Once I've defined that predicate, and the only reason to use predicate is because it's well known within the .NET framework, where my file filter delegate is not, the code looks exactly the same. And this code will return a list of all the files greater than 10,000 bytes. Now let's step over that and go back, and now let's try it with small files. Small files returns all the files, or returns true if a file you pass to it is less than 100 bytes. So this should give me a list of all the files that are less than 100 bytes. And you can see here are the large files, here are the small files, and that works fine. So we've used both our own delegate and a well-known delegate type named predicate to filter based on a condition that we pass in using a procedure. But that really requires creating those procedures ahead of time, and that can sometimes be a problem. If you're going to use it just once, you just have this condition, why create a whole procedure to do the work? That's the point of anonymous methods in C#. C# 2.0 added the ability to pass a reference to a procedure without calling a named procedure. You could pass a procedure block as a parameter, and the compiler generates a named procedure for you and calls it. An anonymous method is useful when you don't need to reuse the procedure. It's a one-off kind of thing. This anonymous method feature in C# is the basis for Lambda expressions, which we'll look at next. Those are available in both Visual Basic and C#, but Visual Basic doesn't support anonymous methods. Here's our sample procedure, which is available only in C#. Here you'll see that we're going to call search for files again, passing in our search path. But this time we'll specify the delegate right here in the procedure. We don't need a separate procedure for this. This one says, I only want to see files where the file length is greater than 100 and less than 10,000, so within that range of sizes. we're going to pass this delegate instance as a parameter to the search for files 6 procedure. So we've essentially specified the condition for the search here within the call to search for files 6. Let's go review how that looks within the code. I'll choose option K for anonymous delegates here, and you'll see that exact code we just saw on the slide. That is, we'll call search for file 6. That's our original procedure, which takes a delegate instance as a parameter. Here our delegate accepts a file info object as a parameter and returns this Boolean value back. It returns fi.length greater than 100 and fi.length is less than 10,000. If we go into the procedure, this code hasn't changed. We're still accepting a file filter delegate condition and then using it to filter the files. And we get the results we wanted. I do want to point out that in our code, wherever that is, should be up here. There it is, anonymous delegates. I could just as easily have called procedure 6A. If I save it and rebuild it, 6A, remember, is expecting a predicate delegate instance. Well, this is a predicate delegate instance just as well as it is a file filter delegate instance, because both cases you pass in an object of a type, and in the case of the predicate delegate instance, it's a generic type that's defined by what you supply, and it returns a Boolean back. Either way, we can call it. This code runs fine as well. I'll call 6A this time, option K. Here we are. We call search for file 6A, and again, we get the list of all the files that are greater than 100 bytes and less than 10,000 bytes. That's all there is. And these techniques, using delegates, named defined delegates in the .NET framework, and anonymous delegates, lead us up to the concept of using Lambda expressions. Many of the LINQ query methods are actually functions that require parameters. And in order to specify parameters to those methods, Lambda expressions were defined. These work both in Visual Basic and C#. Now, if in previous versions of Visual Basic, if they'd supported anonymous methods, we wouldn't really need Lambda expressions in this version, because Lambda expressions are really just simplified anonymous methods. But because Visual Basic doesn't support anonymous methods, we needed some way to indicate a function that defines the behavior of some other function, and that became a Lambda expression. It's really just a delegate instance required by the method you're calling. These act like anonymous methods. They're slightly more limited, as you'll see, but they work in both Visual Basic and C#. Let's look at an example of a Lambda expression that will modify the behavior of a procedure, but isn't a delegate instance. It uses a different syntax and keeps things pretty simple. I'll choose option L here and step into our code. Now you notice here that I'm going to call search for file 6A. That's the one that's expecting a predicate of type file info. You can see here that I'm not passing a predicate. I'm not passing an anonymous method. I'm passing something altogether different. You can see the syntax is fi equals greater than, and then an expression. Well, fi defines the variable I'll use in this expression, and since search for file 6A is expecting a predicate of type file info, fi has to be a file info object for this code to compile. In this case, it is. fi.length is greater than 100, and fi.length is less than 10,000 defines the expression that we'll use in the search for file 6A. So this syntax in C# is pretty much the same as the anonymous method syntax. Just another way to get the same behavior. We're calling the same procedure, we're passing the parameter just in a different way. Here, fi is the name of the variable you'll use in your expression. The equals greater than sign, some people say it means implies. I don't think that word works here. What we're saying is fi, where this expression using fi is true. So if I go to search for file 6a, code's exactly the same. It's still expecting a predicate of type file info. So it took that lambda expression that I specified and treats it as a predicate. And so now it can just call that expression for each file info that I pass it. Here, we can step into it, and it takes us back to the lambda expression that we specified. And as you probably can guess, under the covers, the compiler converts this into a separate function altogether. It gives it a name. We don't know what the name is. It gives it a name and calls it, just like any other method. It returns true if the file meets this criteria and false if it doesn't. And there we go. And you'll see that we get the same list of files we would expect. They're greater than 100 bytes and less than 10,000 bytes. Well, let's try a different example, one that uses a lambda expression for sorting. Let me go option M here. And now I have a different version, search for file 6b, where I'm using a lambda expression to sort things. Well, in this case, I'm using the lambda expression within the procedure. You'll see. Let's come down here, and I don't need to step into that. I'll search for file 6b, and here I'll pass in the same lambda expression as the criteria, the condition for searching. Let's go down here, and I'm going to sort by a particular lambda expression. So everything's the same on my searching until I get to the code that displays the results. Here, I'm calling the order by method of the files collection I got back. Remember, files is here going to be a list of my file info objects defined here. And that list has an order by method. Well, if you've ever studied the list class, you know it doesn't have an order by method. Yet, I have one here. Where did that come from? Well, in the .NET Framework 3.5, one class can extend the behavior of another, giving it special powers, as it were. Well, the system.LINQ.enumerable class provides extension methods for other classes. The order by method is a method, an extension method, that's provided by system.LINQ.enumerable that extends the list class that makes it easy to sort the items in the list. Here is a lambda expression which indicates how we want to sort the items in that list. MFI, I just gave it a name, MFI, it doesn't matter what I call it, but the expression I want to sort on is MFI.length. So MFI.length says order by that length property of the file info object I'm passing to you. Since files is a collection of file info objects, this thing can only be a file info. And I want to check its length as I work with it. Now, if I run this, we'll display the results in sorted order by fileinfo.length. And that makes sense. Let me show you what happens when I type this code. If I come here, I'll just type the whole thing. MFI equals greater than MFI dot. Where did these properties come from? Well, it says up here that files has to be a collection of my file info objects. My file info only has 3 interesting properties: creation time, length, and name, and that's all I see here in my list. So the compiler knows, as I'm writing my code, what the type of object within that files collection is. This is a lambda expression which defines how I want this order by method to work. So the order by method must accept a parameter which is some sort of lambda expression. Let's see. You can see that order by, which is an extension method, you see it there in the definition, is an I-ordered enumerable of my file info. You can see IEnumerable expecting a my file info dot order by, it accepts a func. What is a func? Well, clearly what I typed here works, so it must be whatever a func is. We'll talk about what a func is next. And of course, func is just a specific delegate type. Before we discuss that func thing, we need to talk about lambda expressions and delegates. You can pass a lambda expression to a procedure that's expecting a delegate. As you saw, it certainly worked. And to use a lambda in place of a delegate, the lambda expression must have the same number of parameters as the delegate. Well, in our case, we were passing a lambda expression with one parameter in the place of a delegate that was expecting one parameter. That was our predicate delegate. Each lambda parameter must be able to be converted implicitly to the type of the corresponding delegate parameter. In our case, the delegate was expecting a file info, and our lambda passed a file info. No problem. The lambda return type must be able to be converted implicitly to the delegate's return type. Well, the delegate returned a Boolean, and our lambda returned a Boolean, so there wasn't any problem there. Now, in our example, we supplied sorting criteria. But we didn't supply it as a parameter. We just supplied it built into the method call to that order by method. Now, we could call the order by method in code. That's what we did, and pass a lambda expression specifying the sort behavior. We'll learn more about extension methods in just a minute. But the order by method is supplied by the LINQ.enumerable class as an extension to the list and other classes. We've already seen that. Extension methods are created in one class, and they extend another. So although the method order by is defined in the LINQ.enumerable class, it extends the list class and other classes as well. But you might want to pass that delegate, the sort order, as a parameter. And if you look at the order by method, it expects a func as a parameter. You need to supply a function that determines the sorting order. Well, func is just a delegate type that does the job. Now, it is a generic delegate, so it has a parameter named t that refers to the incoming parameter type. And in the func definition, tResult refers to the returned type. So we're going to look at, again, the example we just saw and examine that func declaration, and then look at an example where we pass an instance of the func delegate type as a lambda expression from the calling procedure. Let's start by looking at the source code. I'm going to go back to the source here and figure out what this order by method is expecting. You'll remember, if I take this out here, order by, you can see that it's expecting a func. A func is a generic procedure which must have specified a myFileInfo here and a key which indicates the value we want to sort by. It is a procedure with two parameters, and we have to specify that. Here, if I put this back the way it was, well, there's our func, but the first parameter is implied. That is the type, and it's right here. But down here, we're going to specify a specific func. We have to specify the type, myFileInfo, and the return type, long, and any procedure which uses a myFileInfo and returns a long could be passed in using this procedure named sorting. And down here, we'll call the order by method, passing that sorting parameter to the order by method, and that will indicate the sort order. Everything else in the procedure is the same as in the last version. Let me run this and look at option N using lambda parameters for sorting. And you'll see here that I'm specifying for search for file 6C, a second parameter which is a lambda expression that identifies my criteria for including a file or not. And here I have a lambda expression which identifies how we want to provide the sorting. This is a func of myFileInfo, long. It takes in a myFileInfo as its parameter and returns back a long. It returns the negative of the file's length. Now, if you sort on the negative of the length, that means that if you're sorting from lowest number to highest number, that means the largest files would appear first, because large negative numbers are lower than 0. In any case, we should get the largest files first, the smallest files last. If we run this full speed, that's what we get. Large to small is how we've sorted. Now, I could, of course, change this. What if I wanted to sort not on the length of the file itself, but on the length of the name of the file? That value has to return a long because that's how we defined search for files 6C. It's returning a sort based on some long integer. If I run this now, just by changing that lambda expression, we should sort not on the length of the file, but on the length of the name of the file in negative order. So here we've changed the sort criteria just by modifying that lambda expression, and we didn't touch the procedure that actually did the work at all. We changed the procedure that called the procedure that did the work, passing a different func parameter that was used by the order by method. What if you want to calculate the total size of files in your list? You could create a method, a standalone method, that accepts a list as a parameter. It would then iterate through everything in the list and calculate the size. To use the method, you would have to know that it exists or use IntelliSense based on some class that contains it, but it certainly wouldn't show up as some method of the list itself. And that would be nice. Wouldn't it be easier if it was a method of the list class? Seems to me it would be. What we need to do is create an extension method that extends the list class that provides the sum of all the files in that list. So we're going to extend the list of myFileInfo class only, so it can calculate the size of the files in that list. You may not yet have created an extension method, but these are methods that allow you to add new methods to existing classes without modifying those existing classes. Now, although this feature is crucial for LINQ, it's not just for LINQ, as you'll see, because we're not working with LINQ here. Extension methods must be declared as public methods. They have to accept a parameter, at least one parameter, the type of which defines the class that you're extending. Because we'll be extending the list of myFileInfo class, we'll need to specify at least a parameter of that type. Extension methods must exist within a class defined using the static keyword, and they themselves must be static using the static keyword. They also must include the this keyword in the first parameter, indicating that the method is extending this particular class. Let's look at an example which extends the list of myFileInfo class, calculating the total size of all the files within that list. If you're attempting to calculate the sum of the links of all the files in your list, again, you could do it two ways. You could create a static method and then call it as a method of the class it lives in, or create an extension method and call it as a method of the list class itself. Well, let's try the first technique. I'll choose option O, static method. And here you'll see I'm going to be calling our search for file 7, passing in here a lambda expression indicating that we just want to retrieve all the files by specifying true as the expression and sorting in negative order on the length of the file. If we go in here, everything's the same until we get done with the procedure. And here, we want to calculate the total size. Now we have an extension methods class which has in it a getTotalSize static method that will pass to that method the files list of myFileInfo. Let me run it full speed to there and now step into that method. And you'll see here in our extension methods class, we have a static method called getTotalSize, which expects a list of myFileInfo as a parameter. It loops through them all, returns the sum back out. And of course, it works just fine. We get a list of all the files and their sizes and the sum of the size, and that works fine. But boy, it seems like it'd be easier if we didn't have to know ahead of time that the getTotalSize method was a method of the extension methods class. Wouldn't it be easier if it was a method of the list class instead? And we can make that happen. I'm going to choose option P and look at an extension method. Here we're calling search for files 7a. And in this procedure, the difference is we're using a different method. You'll see here that we're calling the total size method of the files object itself. And files, of course, is a list of myFileInfo. What this means, and believe me, it works the same as the last one. We get the same result. If I stop debugging and type this one, you'll see that files is the object I care about. That's my collection of files. I type .total. There's a total size property there. It's actually a method. A total size method there that wasn't there before. The list class doesn't have a total size method. Well, where did that come from? Well, let's go back to our extension methods class, and you'll see here within this static class a public static method that returns a long named total size, and it has as its parameter a list of my file info. And the this keyword indicates that this method extends that list. And this method will show up as a method of that list of my file info type. The code inside is exactly the same. I just copied it and pasted it in here. Same exact code. But now in the code where we call it, we can treat it as a method of that files list. And by the way, if you look at the other methods, you'll see lots of extension methods for the list class. We used before the order by method, but now there is also the total size extension method. You can even see the word extension here in the IntelliSense, indicating that total size is extending this class and is coming from some other class altogether. This is the basis of how LINQ works, but it also is useful in your own code. Now you can chain operations using extension methods as well. Imagine you need to take the results of the search and sum the sizes of the 5 largest files. Lots of ways you could do this. You could sort the list by file length in descending order. Then take the top 5, that is the largest files, and then sum the resulting file sizes. Or we could use the enumerable.orderByDescending method, the enumerable.take method to take 5 files, and the enumerable.sum method to sum the 5 files we just took. So there are a number of ways we could solve this problem, but chaining extension methods makes your code a lot cleaner. Let's look at the 2 examples that try this the hard way and the easy way. I'll choose option Q, query methods, and at this point we'll pass in a criteria. I don't want files less than 50,000. I keep changing these just to keep you interested. And I want to sort by negative file length. That's fine. And everything's all the same until down here, after I get the total size, I want to calculate the sum of the top 5 files. Let's get there. Okay, so to do this, I need to, again, sort descending based on the length, take the top 5, and sum based on the length as well. Now, it looks like this one, since I'm ordering by descending based on length, the top files will show at the top. This has no bearing on the value I passed in. This is a new Lambda expression telling this function, order by descending, how to provide its sorting. Here we're saying I want to order by descending using this variable mfi as my index, and I want to sort by the length of each file. Now I take the output from that expression and pass it into the input of take 5. Take 5 says take the 5 topmost items. I take the output from that expression and pass it as the input to .sum. The sum method lets me pass a Lambda expression indicating what I want to sum. Here it is, mfi is the item I want to sum, and it's the length property of that I'm working with. And I'm going to take the output from that and convert it to a string and display that result. So here goes. If we look at this, the top 5 total size is 240, whatever the number is, doesn't matter. But the fact is I was very easily able to chain these methods together, these extension methods provided by the enumerable class, chain them together and get the results I wanted. This is really just one long expression, right? It's files dot order by descending blah 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 dot take 5 dot sum and so on. It's just one big long expression. Now we could have done this the hard way. If I go over and try R, you'll see in this case, with the same criteria passed in, this time I'm going to do it just by calling the methods directly, not the extension methods that extend our list of my file info or anything. I'm calling the methods directly. And to do that, we have to call them in reverse order, which makes things more complicated. I want to call enumerable.sum, passing as a parameter the results of calling enumerable.take, passing as a parameter to take my list I want to take from with its order by method called. I want to take 5 items, and the sum method, now that I've told it what to sum, needs to know how to sum it based on the length. So this gets really complicated trying to write these expressions, and even worse, trying to read them later, because you have to read them in reverse order. What we really want to do is what we did in the last example, which is take our files, order it, take 5, and sum the 5 we got. That's a lot easier to read than this complex expression, although this code does give us the same exact value. So there are multiple ways you can use these extension methods provided by the enumerable class on your data structure. I generally find it easier to chain calls to the methods as opposed to nesting calls directly to the methods. Here we're using extension methods on that list class. Here we're calling enumerable.sum, enumerable.take, and enumerable.order by descending, which are harder to call and harder to use. It's important to understand the relationship between extension and built-in methods. If you have an extension method with the same name as a built-in method, nothing keeps that from happening, the built-in method always takes precedence over the extension method. If the extension method matches the signature of the built-in method, the compiler calls the built-in method. So in every case, if there's a conflict, the compiler will call the built-in method. You need to watch out for writing extension methods. Although they're very useful, you'll want to create them sparingly. It can make your code harder to read. Remember that case where we called the list.orderByDescending method? Where did order by descending come from? Unless you look carefully at the IntelliSense, there's no way to know. And so if you want to go look at the code or modify it, you have to be very careful and keep track of where the extension method was defined. You can't tell just by looking at finished code where that method came from. So, in other words, think twice about using an extension method like that total size method we created. Although it did make the code easier to create, it makes it a little harder to read later on because you can't tell where the method came from if you're just glancing at the code. So far, all of our examples use the MyFileInfo class, and the project contains an explicit definition for that class. But what if you only needed that class for a single operation? We use it over and over again, but imagine you only need it for a single operation. It would hardly be worth creating a class for that. You might be better off allowing the compiler to generate a class for you. And that's the basis of anonymous types. To generate using an anonymous type, I'll choose option S. We'll look at the code here. And in this case, I have search for files 9, which is just accepting a single lambda expression which provides a criteria for a where clause. Let's step into this. Now, this example isn't using the MyFileInfo type at all, and it's using a LINQ query to retrieve just the files it wants. Now, you may not have investigated LINQ very much, but hopefully this query will make perfect sense. We have our items collection, which is all the files, totally all the files. And now, we'll use item as an iterating variable through that collection, from item in that collection, where the condition we passed in, remember the condition here, that specified only files that were, I believe, less than 50,000 bytes in size. We'll order by, using an order by clause, item.length descending. So we have a fixed ordering here, and we're going to select a new type. Now, we're not using the MyFileInfo here. Instead, we're allowing the compiler to generate a type. We don't care what that type is called. It really does generate a new type. And if you look at the IL, you'll see the type in there. And it generates a new type with 3 properties: name, size, and creation time. I can fill in the value for each one, and this is using the object initialization feature that you learned about in the previous section. Name will be the name of the file, size will be the length of the file, creation time will be the creation time of the file. And now, there is no toString method, no fancy toString method, because we're not using them by FileInfo class. When I call console.WriteLine, this is just going to display however the .NET Framework cares to display it, the name, the size, and the creation time for each file. If I run this full speed, we'll get all the files that are less than 50,000 bytes in descending order by file size, and you'll see that each object in this collection has a name, a size, and a creation time property. Those came when we defined this anonymous type right here, indicating what we'd like in our output from running this query.